Hey, what's up, guys? I'm here back. So, today I wanted to learn a bit about statistics because I have to study it in university, but I'm not going to the actual lectures because I have to go to work, and this is the best I can do as of now. Now, granted, I can watch videos which will help me a lot more, but it kind of just feels off watching the videos, so I thought, why not just read the Wikipedia thing, try to go for it bar for bar, uh, sentence for sentence, try to understand everything all together. Hold on, let me get the mic up closer. Personally, I just cannot. I cannot just learn like the chewed up version you learn in school or in university, because they give you very specialized facts that you only understand if you know what they're talking about. Um, Probably a lot of people are like this, I assume. And I've been putting this off for the entire week. I have it on my whiteboard, and I have a bit of time before going to the gym. It's like almost 8. I'm going 9:30. Yeah. So let's get into it. Practically, what I know about statistics from the get-go is that you basically have sort of a unit, or how do you say, an array of data, and you can make predictions based off of it. Now, as I said, I don't really understand a lot about statistics, right? So my interpretation might be really bad, okay? Okay, let's go. Statistics, from German, statistic. Yeah. Description of a state, a country. Statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Yeah, that's a mouthful. Okay, so I got it. Essentially, it is how you organize, how you collect, how you structure data. Okay. In applying statistics to a scientific, industrial, or social problem, it is conventional to begin with a statistical population. In statistics, a population is a set of similar items or events which is of interest for some question or experiment. A statistical population can be a group of existing objects or a hypothetical and potentially infinite group of objects. Okay, so this is like the array I was talking about. Essentially, you have a group of units, right? And you combine them into an array. I'm saying array because it's sort of like, I imagine it's sort of like in programming. So yeah, like you have a list that's full of data, something like that. Okay. To begin with, a statistical population or a statistical model to be studied. Populations can be diverse groups of people or objects, such as all people living in a country or every atom composing a crystal. Statistics deals with every aspect of data, including the planning of data collections in terms of design of surveys and experiments. Okay, so essentially, it's just the magnum opus of all sorts of surveys and experiments, which makes sense, right? You know, possibly every single scientific discovery is based upon something having being repetitive, right? So in a way, having a statistical population, to use the things we just learned. Essentially, if you know it gets dark at night, if you see it happening 5 times, you can make a statistical prediction that is going to happen the 6th time. This is what I'm trying to get at. If I make sense. Okay. When census, I don't know what census means. A census is the procedure of systematically acquiring, recording, and calculating information about the members of a given population. So a census is essentially like if you're from the U.S., right? Uh, what is the age group of people getting married, getting a job, all that stuff? Okay. So your census is the census of the United States. Okay. When census data comprising every member of the target population cannot be collected, statisticians collect data by developing specific experiment designs and survey samples. In the statistics, quality assurance, and survey methodology, sampling is the selection of a subset or a statistical sample of individuals from within a statistical population to estimate characteristics of the whole population. That's kind of difficult. What does that mean? Let me just think. Quality assurance sampling is a selection of a subset or a statistical sample. Okay, so it's like taking this guy represents the whole entirety of a country or whatever. Okay. Representative sampling assures that inferences, I don't know what inference is. Inferences is meaning. Okay, a conclusion. See, we're getting smarter. Conclusion reached on the basis of evidence and reasoning. Inferences. Inference. Oh, my mouse just disconnected. My bad. Yeah, it's gonna keep doing that. Come on. And conclusions can reasonably extend from the sampling to the population as a whole. An experimental study involves taking measurements of the system under study, manipulating the system. What? Manipulating the system and then taking additional measurements using the same procedure to determine if the manipulation has modified the values of the measurements. Let me read that again, it doesn't make sense to me. An experimental study involves taking measurements of the system under study. Okay. So the group manipulating the system and then taking additional measurements using the same procedure to determine if the manipulation has modified the values of the measurements. Okay, I kind of get it. Let's say it's a bear. So first you take a look at the bear, okay, then you poke the bear, and then you take a look at the bear again and see if you poking the bear had any effect on it. Anyways. In contrast, an observational study does not involve experimental manipulation. So that would be sort of like just observing. Psychology and statistics. Well, why is my nose running? Anyways. Two main statistical methods are used in data analysis. Descriptive statistics, which summarizes data from a sample using indexes. Composite statistic. Oof, so many complex words. Composite statistic, such as the mean or standard deviation. Okay. So how would a curve essentially? And inferential statistics, which draws conclusions from data that are subject to random variation, e.g., observational errors, sampling variation. Okay. I mean, that's not that important to understand, I guess. It's just telling you the two different ways. Descriptive statistics are most often concerned with two sets of properties of a distribution, sample or population. Central tendency, let me just read up on that. In statistics, a central tendency is a central or typical value for probability distribution. Okay, so that's 0.0, I guess. In a coordination system, that would be just the middle. Okay, that would be the middle of your screen if you're making video games. Okay. Or a location seeks to characterize the distribution's central or typical value, while dispersion, in statistics, dispersion is the extent to which a distribution is stretched or squeezed. Common examples of measures of statistical dispersion are the variance, standard deviation, and interquartile range. Interquartile. What the hell? For instance, When the variance of data in a set is large, the data is widely scattered. Okay. Or variability characterizes the extent to which members of the distribution depart from its center and each other. Inferences made using mathematical statistics employ the framework of probability theory, which deals with the analysis of random phenomena. My bad. Probability theory. Probability theory or probability calculus is the branch of mathematics concerned with probability. Figure that one out. Although there are several different probability interpretations, probability theory treats the concept in a rigorous mathematical manner by expressing it through a set of axioms. Okay, just to break that down. Probability theory. Although there are a lot of different interpretations, RNG. Okay, probability theory essentially explores RNG in the most autistic and how do I say that? Scientific way. So all the tests. Okay, that's good. I'll read the entire thing, but like I'm more concerned statistical data. Like I think the idea of statistics is sort of kind of get that, but let me just try to find something on finance. Statistical finance. I imagine there's econ physics. Oh my god, that's so crazy. I imagine there's about like 30 different pages on every single deviation or field of study related to finance and statistics because, well, it just makes sense. Let me just see which statistical physics. Angel investor. This actually, I found that today while at work. This is actually a pretty useful area of the Wikipedia page. Asset growth, too big to fail. These are like some theories. I like to check that out too. You know, this looks interesting. Too big to fail. This is like a hype train, I guess. Is a theory in banking and finance that asserts that certain corporations, particularly financial institutions, are so large and so interconnected with an economy that their failure would be disastrous to the greater economic system, and therefore should be supported by government when they face potential failure. This is a colloquial, I think I did it, term. Too big to fail was popularized by U.S. Congressman Stuart McKinney in 1984. Congressional hearing discussing the Federal Deposit Insurance Corporation's intervention with Continental Illinois. Let's check that out. Oh, that's a trust company, Continental Illinois. The term had previously been used occasionally in the press, and similar thinking had motivated earlier bank bailouts. Okay, I don't need all of this. I sort of get it. Yeah. So if like a company that owns, let's say BlackRock, if BlackRock fails, there's a wide chance that every single institution, company, and altogether everything would sort of like a chain react in a negative way and fail, most likely. I don't know how I mean, we've seen it. Let's see this part because it says the Great Depression of interest. The term emerged as a prominent in public discourse following the 2008 financial crisis. Very interesting. Critics see the policy as counterproductive and that large banks or other institutions should be left to fail if their risk management is not effective. Sorry for the breaks, I'm smoking. Some critics, such as economist Alan Greenspan, believe that such large organizations should be deliberately broken up. If they're too big to fail, they're too big. Okay, I guess that's not a bad criticism. Some economists, such as Paul Krugman, hold that financial crises arise principally from banks being underregulated rather than their size, using the widespread collapse of small banks in the Great Depression to illustrate this argument. I mean, I wouldn't say that these two things don't coexist. If they're too big to fail, they're too big. Does not mean we should. It kind of goes hand in hand. So if you want to regulate things, you probably have to chop things up. That makes sense. Okay, that was an interesting side note, but not really what I'm looking for. No Wikipedia. Probably this would work. Economics. Economic statistics. Let's go. And this probably is... Okay, that's not that bad. But... Okay, let's read the entire thing. See, this is not a well-structured video that I'm going to show you. It's just my process of sort of understanding everything. So you have... like the only thing you're going to study in business... the supply and demand model, right? Okay, like it's such a meme at this point, but it's so true. Okay. Anyways, economic statistics is a topic in applied statistics and applied economics that concerns the collection, processing, compilation, dissemination, and analysis of economic data. It is closely related to business statistics and econometrics. Okay. It is also common to call the data themselves economic statistics, but for this usage, economic data is more common of a term. Overview. Just to clear that up, it's essentially what we read in like the first page. It's just a compilation. You take a lot of data, you study it, and you run your tests on it. The data of concern to... The data of concern... Okay. Sorry, I'm a bit fried. The data of concern to economic statistics may include those of an economy within a region, country, or group of countries. Economic statistics may also refer to a subtopic of official statistics for data produced by official organizations, e.g., National Statistical Services, intergovernmental organizations such as United Nations, European Union, or OECD, central banks and ministries. Analyses within economic statistics both make use of and provide the empirical data needed in economic research, whether descriptive or econometric. My bad. They're a key input for decision making as to economic policy. The subject includes statistical analysis of topics, the problems in microeconomics, macroeconomics, business, finance, forecasting, data quality, and policy evaluation. It also includes such considerations as what data to collect in order to quantify some particular aspect of an economy and of how best to collect in any given instance. So the last part is playing the game for the sake of playing it, I guess. But yeah, it's I think it's pretty easy to just size it up as we use it to see if people in our country are poor. This part, um, and we also use it to measure how we would employ be the right word, policies, the policy evaluation. Yeah. Let's press this one. Income distribution, money supply. Bankruptcy statistics. That's interesting. Great Depression statistics. Hold on, let me get a drink of water. Wealth statistics. And we just have a lot of charts. Biggest arms sales. Interesting. Wikipedia is just full of some crazy stuff, man. It's like probably the greatest tool we've all had to encounter. That I guess I have the wisdom of, I believe that it's better to just read some random stuff, because I remember when I was a kid, like I was in school, my teachers would tell me, don't trust Wikipedia, it's not accurate. But it is very accurate now. It's like pretty accurate. Anyways, okay. I'm just trying to see if anything relates to what I'm looking at. Yeah, it's used in everything. Wouldn't statistics be like, okay, I don't know, introduction to statistics. And it's this guy who's pretty cool. You should go and look at him. He helped me pass my first year at uni. But yeah, it wouldn't be right to go ahead and watch an entire video. But I'm not awfully interested in learning every single example of what statistics is used for. This sounds interesting. Misinterpretation. Misuse of statistics can produce subtle but serious errors. Yeah, I can kind of guess that. Okay, let's read this and see if it gets me somewhere. In business, statistics is a widely used management and decision support tool. It is particularly applied in financial management, marketing management, and production services and operations management. Statistics is also heavily used in management, accounting, and auditing. The discipline of management science formalizes the use of statistics and other mathematics in business. Econometrics is the application of statistical methods to economic data in order to give empirical content to economic relationships. Okay, I think this is actually the thing we need. Okay, let's finish this up and I'll take a look at econometrics. A typical business statistics course is intended for business majors and covers descriptive statistics, collection, description, analysis, and summary of data, probability, typically the binomial and normal distributions. Binomial, what does binomial mean? In probability theory and statistics, a binomial distribution with parameters n and p is a discrete probability in so many words. and normal distributions, test of hypotheses and confidence intervals, linear regression, and correlation. Follow on courses may include forecasting, time series, decision trees. I had that in school. Yeah, it was related to programming. Anyways, decision trees, multiple linear regression, and other topics from business analytics. More generally, professional certification programs such as the CFA. Actually, my boss, he kind of recommended me this. Often include topics in statistics. It was like I would go there, and he sent me a link, sort of like what you call it, conference. Yeah, he said you have to like study on your own, like about 500 hours or something like that. And I was like, I can do that. Like I've done more for less, but am I that interested? Maybe if I get very interested in the topic in general. But for right now, I don't really need a certificate of that. Okay, let's look at econometrics. CFA, actually, just to explain a bit, CFA is sort of like it's like a certificate for being data analysis. Chartered financial analyst. Okay, yeah. So this is better explained than me. You essentially study on your own. It's not like a college sort of thing. It's an association. They give you the test, and it's pretty difficult. So if you pass it, you probably guaranteed a job until you die. But it's like really hard. It's like the opportunity cost, right? Would you rather do this or do that, sort of thing? And I just don't know yet if I want to get that deep into it. Like my job is how would I say? It's pretty comforting. Like it's not a hard job. It's not like the hardest job I've had, but it's it doesn't pay that well. That's all I'm gonna say. It pays pretty badly comparing things that if I study a lot less and just work a lot more, I can probably get more. Anyways, let's look at the econometrics. Sorry for talking about myself so much. Okay, econometrics is an application of statistical methods to economic data in order to give empirical content to economic relationships. What would that mean? Economic data in order to give empirical content to economic relationships. So it will be, I guess, if there is an increase in car production, let's say there's an increase in car production and the price of cars falls, it wouldn't be crazy to assume that gas would rise up, right? A lot more consumption. Yeah, okay, I kind of get it. More precisely, it is the quantitative analysis of actual economic phenomena, like a black swan event, something like that, based on the concurrent development of theory and observation related by appropriate methods of inference. I know what inference means now. It's like something that's factually correct, right? Let's check it again. See, that's how you study languages. You just say a bunch of words over and over until yeah, it's factually sound. You repeat a bunch of words that you don't really understand until you just it becomes muscle memory. That's how I'm learning French. An introductory economics textbook describes econometrics as allowing economists to sift through mountains of data to extract simple relationships. Okay, but that's very like, how would I say? That's like very abstract. Jan Tinbergen, I don't know if I'm saying your name correctly. Well, he's Dutch, so is one of the two founding fathers of econometrics. The other, Ragnar Frisch, also coined the term in the sense in which it is used today. Basic tool for econometrics is a multiple linear regression model. Let me take a look. Okay. We'll probably take a look at that. Yeah, we'll take a look at that. Econometric theory uses statistical theory and mathematical statistics to evaluate and develop econometric methods. Econometricians try to find estimators that have desirable statistical properties, including unbiasedness, efficiency, and consistency. Applied econometrics uses theoretical econometrics and real-world data for assessing economic theories, developing econometric models, analyzing economic history, and forecasting. History, not important for this one. Sorry. A basic tool for econometrics is the multiple linear regression model. In modern econ, other statistical tools are frequently used, but linear regression is still the most frequently used starting point for an analysis. Estimating a linear regression on two variables can be visualized as fitting a line through data points representing paired values of the independent and dependent variables. For example, let me just sit on this for a moment. Estimating a linear regression on two variables can be visualized as fitting a line through data points representing paired values of the independent and dependent variables. Yeah, I need this shown up. Oh, okay. Okay, I guess we'll get it explained a bit. For example, consider Okun, Arthur Melvin Okun. This is a very weird name, but anyway. Okun's law, which relates GDP growth to the unemployment rate. This relationship is represented in a linear regression where the change in unemployment rate. So this triangle means all of the unemployment, I guess. A combination of minus unemployment and surplus. So deficit unemployment and surplus unemployment. Surplus unemployment is a function of an intercept, a given value of GDP growth multiplied by a slope of a coefficient B1 and an error term E. So the entire unemployment equals times growth plus E. The error term is like room for error, I guess. The unknown parameters B0 and B1 can be estimated. Here B0 is estimated to be 0.83 and B1 is estimated to be minus 1.77. Oh, okay. I think I got it now. That means that if GDP growth increased by 1 percentage point, the unemployment rate would be predicted to drop by 1.77 times 1. GDP growth increased by 1 percentage. So you multiply okay. Other things held constant. Ceteris paribus. Other things equal. Empirical moral logical relations. The model could then be tested for statistical significance as to whether an increase in GDP growth is associated with the decrease in the unemployment as hypothesized. Okay, this is actually kind of crazy. I think we need to understand this. Okay, Y and X. Okay. This line right here. Is that R? Is that R2? Maybe if it's written somewhere. Okay, so if we increase it, yeah, probably a lot less people will be unemployed. Okay. I kind of get it, but I need more examples. Uh, if if the estimate of B1 were not significantly different from zero, the test would fail to find evidence that changes in the growth rate and unemployment rate were related. The variance in a prediction of the dependent variable, unemployment. This is what you are, by the way, unemployed. As a function of the independent variable, GDP growth is given in a polynomial least squared. Oh, it's what that. Okay. Linear regression. You know how after work you you're a bit fried. I don't know how to explain it. It's like you're an autopilot. Like your thoughts are in the back of your mind. Sort of giving yourself a reason to do these sort of things. It just makes it easier. Yeah. So in a way you help me. If I help you somehow, I'm happy, but you help me. Okay? Thank you. Oh my god. Oh my god. Why is it so long? It's just a formula. It's a motto. It's gonna be long as hell. I might have to miss gym. Nah, I don't miss gym. Let me just take a look how long. It's been 40 minutes, alright. Let me get a second to just think. Just to say some stupid stuff to get it out of the way. Oh, yeah, today I'm gonna be working out arms. I had a buddy tell me to fix up a few things in my regimen. I might make a video on it, but I'm not that ripped to think that I would qualify for making videos about a regiment or something like that. But if anyone is interested, just let me know in the comments. It'll be cool. I think you'd like it. Um, yeah, but I think gym is important. I was talking with another buddy of mine who said he lost he lost sort of the will to go to the gym, and I said in that situation the perspectives change because I've been through this process like countless times. You like stop and then you start again, that sort of thing. Like obviously if you work and you go to university, sometimes you just don't have time. Sometimes you don't have time. Yeah. But not for real. It's not expected of you to be that consistent. I think the important thing is sort of the process of understanding that you're kind of sick of it. Like it is not something you look forward to, and changing your goal. When I started getting sort of sick of the usual lifting weights, sort of thing, it becomes a routine and it's not that fun. I started running and preparing for a marathon, and it was pretty fun. I'm pretty skinny, so I got even skinnier, but not like in the like my ribs weren't showing. It was sort of like it's just my pecs look better, my biceps look better. It just reinvigorated me to keep working out because I had another goal. And I went to that marathon. I was wearing like cotton. Everyone was wearing shorts. It was like 30 degrees outside. It was hot as hell. Uh, it was so bad. And I was wearing these long cotton pants. It was horrible. I still finished though. I still finished. That was cool. I still have like the number they give you. It's like a pin to my door, and I look at it sometimes. I'm like, hell yeah. You need to delve into these sort of adventures that life throws at you sometimes. It's very fun. I take this one as sort of like another one of them. So yeah. Okay, I'm almost finished with my cigarette. So I might as well just finish this tangent up. Okay. In statistics, linear regression is a model that estimates the relationship between a scalar response. Scalar response, these vector space. Let me read that for everyone that's not looking at their phone or computer. A scalar is an element of a field which is used to define a vector space. A vector space would mean I have to open up. It's like a few points. It's like okay, I guess. In linear algebra, real numbers or generally elements of a field are called scalars. Real numbers or generally elements of a field are called scalars. Okay. And one or more explanatory variables, regressor or independent variable. A model with exactly one explanatory variable is a simple linear regression. A model with two or more explanatory variables is a multiple linear regression. This term is distinct from the multivariate linear regression, which predicts multiple correlated dependent variables. What even is this image? What am I looking at? Are those chromosomes? No. Oh, okay. I think I got it. These are like points in a coordination system. I think that's the right term. If my brain is messed up. So the first one is like positive. Okay. So in the middle you have the line. Up you have like the data, like the units of data. You got the middle one that's like okay, so sort of makes sense. In statistics, correlation or dependence is any statistical relationship, whether causal. Oh, I'm so cooked, man. Causal or not between two random variables or bivariate data. Bivariate data, what does that mean? I need like a hyperlink to the hyperlink. This is crazy. I have never needed that in my life. The word bivariate. And I'm gonna learn it just for the hell of it. Okay. Dependent variables rather than single dependent variable. In linear regression, the relationships are modeled using linear predictor functions whose unknown model parameters are estimated from the data. Most commonly, the conditional mean of the response given the values of the explanatory variables or predictors is assumed to be an affine function of those values. Yeah, I need a lot more of those. Let me think of it. In linear regression, the observations, red, are assumed to be the result of random deviations, green, from an underlying relationship, blue, between dependent variable y and independent variable x. Okay, so you model the curve after the deviations, or you just take a look, linear the observations red are assumed to be, or you just look for the observations of the random deviations in relations to the observations. So these are systems, I guess. Yeah. Often these n equations are stacked together and written in matrix notation. Sometimes I think these mathematics scholars are just rappers, bro. Often these n equations are stacked together, written in matrix notation. Yeah, I'm definitely gonna need to look at a lot of tutorials, but for the sake of this video, I think I'm gonna end it here, guys. It's been 45 minutes. My brain is cooked. I need a second. I need to watch something stupid on my phone. I need to write in with a couple of friends. But yeah, if you're interested in sort of these non-structured, because I took a lot of tangents in this video. I wasn't just looking at one specific thing. It was just where my imagination and, how would I say it, curiosity brought me. Yeah, if you're interested in this, just let me know. I don't really like making structured things. I'm not that good at it, and it's not that entertaining to me. And if it's not fun to me, it probably wouldn't be fun to anyone watching this. So I look at it from that perspective. But yeah, thank you. Have a good day, and watch a better video than this to understand it, because I don't think anyone would get a decent understanding of linear regression and econometrics and statistics when it comes to finance from watching my video, but it still was fun. We learned a few things. Yeah. See ya.